Last part of the electrochemistry video. In this video, I shall be discussing about the conductors, conductivity, conductance, and the molar and normal conductivities. So let us begin with the little bit of physics and decide that what is the difference between electronic and the electrolytic conductors. So what are electronic conductors? In this type of conductors, there is no decomposition of the electrons. Here the electrons, in electronic conductors, the electrons will be the charge carriers. So we know in physics that there is no decomposition of electrons, hence these are the electronic conductors. Now what are electrolytic conductors? When current is passed, we can see the decomposition of the particular ions. There is decomposition of ions. So like we can take as strong acid plus weak base, weak acid plus strong base, etc. So these are the case where we have electrolytic conductors. Now we all know from physics that R is equal to rho L upon A. Now taking rho to the other side, so I get 1 by rho is equal to 1 by R into L by A. Now 1 by rho is known as conductivity and 1 by R is known as conductance. This is known as conductance. This is known as conductivity. I will be denoting conductivity by K and conductance by C. So what we can generalize the formula as C is equal to K into L by A, where L is the length and A is the area. So we can see that L by A is a particular constant that we get for a cell because the ratio has to be a constant. So this L by A is known as the cell constant. Now these type of things are important for JEE mains, not for JEE advanced. Okay, so L by A is known as the cell constant. Other formulas we know that V is equal to Ri and all the other basic formulas that we derive from physics. So now let's get along to the molar conductivity. Now what is molar conductivity? Molar conductivity is represented by the symbol lambda m, which is equal to 1000 K by m. Now what is molar conductivity? K is the conductivity of the solution that we take and m is the molarity. Okay, so this is molar conductivity. Now what is normal conductivity? So lambda n, or it is also written to be as lambda e, which is also known as equivalent conductivity, is equal to 1000 K by n. So what is this normal or equivalent conductivity? Okay, so these are two basic terms. From mole concept we all know that n is equal to n factor into n factor. This is n factor. So n factor into molarity, hence we can relate molarity and normality, and hence we can also relate the molar and the equivalent conductance. Now we all know by a rule in NCERT that lambda m is equal to lambda m infinity minus b root c. This is a basic relation that has already been asked once in JEE mains. So this is the Huckel and Debye rule. So this is used for the strong electrolytes. Now let me show you a graph, which is experimental by the way. So this graph is drawn between lambda m and root c. So let me take two lines, one by the red color and one by the blue color. So we can see that this equation is for strong electrolytes, hence the plot for this equation will be a straight line because we can take this to be y, this can be taken as x. So on plotting we get a straight line. So this is for the strong electrolytes. Okay, now this is for the weak electrolytes. The red chart, the red graph is for the weak electrolytes. I hope this is clear yet. So now let's move on further. Now let me take simple examples to prove you how to solve particular questions. So a basic question that is asked is for lambda E. So lambda E of CH3COH is asked. Okay, given that lambda E naught of CH3CO minus Na plus, that is of its salt, is A lambda E naught of HCl is equal to B, lambda E naught of NaCl is equal to C. So we have to derive this from these things. Now how to derive? It is same like thermodynamics that we used to do in thermochemistry. So how we can derive it? This can be written as CH3CO minus, means lambda of this plus lambda of Na plus is equal to lambda E of CH3CO minus Na plus, because we know individual conductivities can be added. So we are just adding the basic equations. From the second equation I can get lambda E naught of H plus lambda E naught of Cl minus is equal to lambda E naught of HCl. Okay, and from the third equation I get lambda E naught of Na plus lambda E naught of Cl minus is equal to lambda E naught of NaCl. Now what we do, let me replace this value. Now this value is given to be A, so let's put A here. This value is given to be B, and this value is given to be C. Now what I do, I want to derive this thing. So this thing can be written, the question is asked is CH3CO minus plus lambda E naught of H plus. So I have to derive this thing from these three equations. Now how to derive? Let's reverse the equation number 3. Reverse 3. So if you reverse 3 and then add 1 plus 2 plus reverse of 3. So if I reverse this, so it will become minus C, and this will go to the other side. So if I add 1, 2 and reverse of 3, I will be getting Na plus and Na plus to be cancelled, Cl minus and Cl minus to be cancelled. Basic algebra. So what I get? So I get this thing which I was needing to derive the equation. So the thing will be A plus B minus C. A plus B minus C, because we are reversing the direction. Now let me tell you a very important thing here, that when we have AlCl3 or MgCl2 etc., means which can be dissociated, like it can be dissociated into Al plus 3 plus 3Cl minus. So basically I will be getting 4 ions basically. Here I was getting only 2 ions. So it was an easy question. Now how to solve such type of questions? We have to take a particular value of n multiplied to the particular ions. Okay, let's see. So if I have to say lambda E naught of AlCl3, that will be lambda E naught of Al plus 3 plus lambda E naught of Cl minus. We have to not place a 3 here. We have to not place the 3 here. But if I take lambda M naught of AlCl3, means the molar conductivity, so it will be lambda M naught of Al plus 3 plus 3 lambda M naught of Cl minus. So here I have to place a 3 here. So this is one very important point that you have to remember during the mathematical calculations for such type of questions. Okay, so let us take another example to prove it. If I have MgCl2, then the lambda E naught will be just the summation of the lambda E naught of the particular ion. So it will be lambda E naught of MgCl2, it will be Mg plus 2 plus lambda E naught of Cl minus. But what will be the value of lambda M for MgCl2? It will be lambda M naught of Mg plus 2 plus 2 into lambda M naught of Cl minus. Here we have to multiply by 2, because in molar conductivity you have to take the number of ions also. So this was one important point. I hope that this video helps, and if there are any questions you can definitely ask me at the end of the video. Thank you.